So today topic is dimension and basis and along with linear combinations. So first of all, what is a linear combination? First definition, a vector beta in a vector space V is said to be a linear combination of the other vectors, n number of vectors, alpha 1, alpha 2, and so on, alpha n in V. If there exists a scalar C1, C2, and so on, Cn in the field such that alpha here beta equal to beta is a linear combination of other vectors. Beta value is equal to linear combination of the vectors C1 alpha 1, C2 alpha 2, and so on, Cn alpha n. Then beta is said to be a linear combination of n number of vectors alpha 1, alpha 2, and so on, alpha n. So based on this definition, we have a problems. For example, here I am providing 4 problems. I will solve 2 problems. So first problem, linear combination of other vectors. So problem 1, write the vector. So write the vector x is a linear combination of x1, x2 in the vector space V3. So we don't know scalars, say C1, C2, because here we have two vectors, x1, x2. X is written in terms of x1 and x2. N value is here 2 because they provided two vectors. The given vector is converted into linear combination of these two vectors. So answer whenever here x1, x2 be the given vectors. This vector x is written as a linear combination of these two vectors. So let x is a linear combination of x1 and x2, where x1 comma x2 are field element, field, either it is real field or complex field, whatever it may be. Now substitute the x value and x1 value, x2 value. So x value in the left hand side is 3 tuple. C1 times of 1 minus 3, 2, plus C2 times of 2 minus 1, 1. Now 1, 7 minus 4 in the left hand side. It is a 3 vectors, 3-dimensional vectors. Add 3-dimensional vector. First, enter C1 inside the 3 tuple. It becomes like this. Multiply each component with C1. Similarly, in the second factor, multiply with C2. Now, sum of the two vectors. In the left hand side, we have two vectors, 3 tuple. Adding 3 tuple by addition property, component wise addition. First component C1, here first component is 2C2, 2C2. The second component in the first tuple is minus 3C1, here minus 3C2, minus C2. Next, 2C1 plus C2. 3, the tuples are equal only when the corresponding components are equal as per n-dimensional or dimensional vectors. Corresponding vectors are equal to first vector is equal to 1. Similarly, second vector equal to 7, this vector. Third vector 4 is equal to third vector. So from this you get okay. From this we get C1 plus 2C2 equal to 1, minus 3 1 minus C2 equal to 7, 2C1 plus C2 equal to minus 4. So what about C1 and C2 value? Solving two variables are there, C1, C2, but we have 3 equations. We are happy. We required 2 variables. two independent equations. Now we have three equations. Taking any two, either first and third or first and second, as your wish. Solving any two equations. Then we get, for example, I am solving first one and third one. So I want to eliminate C1 first. So multiply the first equation with 2. It becomes like this. Second equation with 1, because the C1 coefficient in the first equation is 1. Now subtracting, it becomes negative. This value is 3C2. This value minus into minus plus 2, 6. This is becomes plus. That implies C2 equal to 3. Substituting in any one of these two equations, not in other equations. Substituting in C1 plus 2C2 equal to 1. Then we get C1 equal to 1 minus 2 times of 3. 1 minus 6 equal to minus 5. So whether our answer is right or wrong, we can verify by substituting these two values in the another equation. C1 equal to minus 5, C2 equal to 2. Input in remaining equation. Minus 3C1 minus C2. Substituting here, we get RHS are not verified. If we get RHS, our answer is right. Otherwise, our answer is wrong. Minus 3C1. Minus 3C1 means minus 3 times of 3. Minus 3 times of 3, not 5. C1 value is minus 5. C2 is only 3. Okay, minus 9, minus 3. Okay, somewhere x equal to C1 plus C2. Write the vector as a linear combination of the vectors x1, x2. x1 value is 1, 3, minus 4. Here 1 minus 3, 2. 2 minus 1, 1. C1, 1, minus 3, 1, 2 C1, 2 C2, minus C1, right. Up to this, right. Here also, right. Solving any two equations, we get C1, C2, C1 plus 2C2, because these two are independent, not this equation. So don't bother about it in the substitution value. Well, after finding these two values, substitute in our two equations only, not in third equation. Whether our answer is right or wrong. Solving after C1 value is minus 5, C2 value is 3. Substituting either first equation or third equation, because we take these two equations. Minus 5 plus 3. Plus 3 means 6. Minus 5 plus 3, 6. 6 equal to plus 1, right. The second equation, minus 5 minus 10 plus 3 equal to minus 6. Minus 5, 5 to 10. C2 value is 3. Somewhere I made a mistake. 2C2 plus 4C2 equal to 2. Minus C2, not minus, 2C2 plus 2C1 plus C2 equal to minus 4. Subtracting these two, this is 0, 3C2. Here 4 plus 2, 6. C2 at least 3, 2. So I made a mistake. That's why we get a wrong answer, C2. Substituting here, 2. Now we get this value is minus 4. Now this value is minus 3. Substituting C1 equal to minus 3, C2 equal to 2 in any two equations or three equations. minus 2, minus 3. Minus 3 into minus 3 plus 9, minus 2 plus 3 plus 9 minus 3 is 7. 7, right. Our answer is right. Now it's okay. That's all. Leave it. Therefore, finally you write down substitute C1 and C2 values. C1 and C2 values in the equation 1. Substitute C1 equal to minus 3, C2 equal to 2 in equation 1. 1, 7 minus 4. 1, 7 minus 4 equal to C1 times minus 3 times of first vector, x1 vector. X1 vector value is 1 minus 3, 2. 1 minus 3, 2. 1 minus 3, 2 plus C2 means 2. 2 times of C1 x1 value. X1 value is 2 minus 1 minus 1. Sorry, 2 minus 1 1. That's all. This is the linear combination of. You can verify LHS value and RHS value. RHS value verify minus. First component is minus 2 plus 4 equal to 1. Second component is plus 9 minus 2, 7. Third component is minus 6 plus 2 minus 4, right. Our answer is right. Next problem. For what value of k? Second problem. For what value of k? It is a linear combination of the other three vectors. Next problem. So, same procedure. Answer. Let vector x equal to c1 times of x1 vector plus c2 times of x2 vectors, where c1, c2 are field element, where c1, c2 belongs to some field element. Now we want to find k value. 1k5 equal to first of c1 times of 1 minus 3, 2 plus c2 times of 2 minus 1, 1. As usual, routine procedure. So in the left hand side we have 3 tuples, right hand side also 3 tuples, but summation of 3 tuples. Adding these 3 tuples by using addition property of components, we get c1 plus 2 c2 is the first component, minus 3 1 minus c2 is second component, 2 c1 plus c2 is the third component. Two vectors are, 3 tuples are equal if and only if the corresponding coefficients are equal. First component equal to first component value, second component equal to second component value, third component equal to third value. Here, using these two, we get C1, C2. Later substitute here, we get K value. That's all. Solving C1 plus 2 C2 minus 1, 2 C1 plus C2 equal to 5. That is 2 C1. As your wish, you whatever the method you applied, as your wish. No restriction. Our intention is to find C1 and C2. Now multiply first equation with the 2, it becomes solving these two in the 0. This is 3c2 equal to minus 3. That implies c2 equal to minus 1. Substituting c2 value in any one of the equation. So c1 equal to 1 minus, I am substituting in the first equation, 1 minus 2 times of minus 1, which is equal to 3. Therefore, c1 equal to 3. Now observe that our answer is right or wrong. Substituting in this equation, c1 value 3, c2 value 1, minus 1, it becomes 3 plus 2 into minus 1. 3 minus 2 equal to 1, right. Here also 3 into 2, 2 into 3 means 6. 6 minus 1 is 5. Our answer is right. substituting these two values in the middle equation, because in the middle equation we have a relation with k. C1, C2 have a relation with k. We get a k value. Substituting C1 equal to 3, C2 equal to -1 in the equation, minus 3C1 in the second equation, middle, minus 3C1 minus 3C2 equal to k. That implies minus 3 times of 3 minus of -1 equal to k. That implies -9 plus 1 equal to k. That implies k equal to -8. That's all. K value is -8. That's all. This is the second problem. Third and fourth I will explain and do yourself as a homework or assignment problems. Our topic is linear combination. Third problem. Write the vector as a linear combination of the vectors x1, x2, x3. In the first problem, we have only two vectors. N value is 2. Now, in this problem, n value is 3. You take C1, x1 plus C2, x2 plus C3, x3 equal to x vector. X vector equal to C1, x1 plus C2, x2 plus C3, x3. Find similar manner, you can find C1, C2, C3. We get three equations in three variables, solving in either matrix method, echelon form method, or whatever it may be. Eliminate one variable from these three equations. We get a two equations, two variable, and once again eliminate one variable from the two variable equations. We get a one variable value. Later back substitution, we get the value as your wish. Similarly, fourth problem also. This is the topic of linear combination. Next topic, linearly dependent and linearly independent. Linearly dependent, the set of vectors x1, x2, and so on, xn is said to be linearly dependent if there exists a scalars alpha 1, alpha 2, and so on, alpha n, not all zeros. At least any one of them is non-zero, such that this linear combination alpha 1 into x1 plus alpha 2 into x2 plus alpha n into xn equal to 0. Then this set of vectors is said to be linearly dependent. Linearly independent means there is no any set of non-zero scalars. All should be 0. Alpha 1, alpha 2, alpha n should be 0 if and only if alpha 1 x1 plus alpha, this linear combination is 0 if and only if their coefficients alpha 1, alpha 2 value should be 0. This is called linearly independent. In the first case, any one of them is non-zero. Alpha 1, alpha 2, and so on, alpha n, any one of them is non-zero. These two are the definitions of linearly dependent and linearly dependent. Now we are going to see the problems. First problem, show that the set of vectors is a linearly dependent. So, linearly dependent. As per definition, equate to 0 and find alpha 1, alpha 2, alpha 3 value. Or if you have any confusion, C1, C2, C3 value. Whenever we want to show that linearly dependent, linearly independent, take here we have three vectors, four vectors. Take C1 into x1, C2 into x2, plus C3 into x3, plus C4 into x4. Let equal to 0 vector. Usually, here vectors are three tuples. 0 vector nothing but a three-dimensional 0 vector. You understand yourself. That implies now we want to find C1, C2, C3, C4 value. If all are zeros, then it is said to be linearly independent. If any one of them is non-zero, then it is said to be linearly dependent. That's all. C1 into first vector 1, 2, 3 plus C2 into second vector 1, 0, 0 plus C3 into 0, 1, 0 plus C4 into 0, 0, 1. I substitute the vector values. Now, in the left hand side, you have a constant multiple of vector. Send the constant inside, it becomes 0 into scalar equal to 0. So I put a 0. 0 into C4 not necessary. 0 into C3 not directly right. Now it is a sum of the vectors. Adding the vectors in the left hand side. So 2C1 plus C3 third vector 3c1 plus c4 equal to 0 vector. Now we have three vectors left hand side, I mean three component left hand side as well as three component in the right hand side. Equate the corresponding component. First component, second component, third component, third component. Oh, okay. Now solving any two. From the first equation, it becomes minus c1 equal to c2. Substituting this in this equation, 2c1 or no use. C1 value is C2 from the first equation. From the second equation, 2C1 equal to minus C3. Okay. From the third equation, C3 equal to minus C4 by 3. From this equation, C1 equal to minus C3 by 2. Now, every value depends on C1. It means C1 value is C1 equal to minus C2. C1 value from this equation equal to minus C3 by 2. This value equal to minus C4 by 3. Now, if C1 value is 1, then C2 value becomes minus 1. C3 value becomes minus 2. C3 value becomes minus 3. Therefore, every value equal to K same. K is some constant. Take any K equal to 1, 2, not necessarily 0. So, therefore, there exists non-zero scalar. Let K equal to 1. Then C1 becomes 1. C2 equal to minus 1 because C2 equal to minus C1. Similarly, C3 equal to minus 2, C4 equal to minus 3, such that C1 into vector x1 plus C2 into vector x2 plus C3 into x3, C4 into x4 equal to 0. Therefore, vectors x1, x2, x3, x4 are linearly dependent, LD. That's all. Because all are non, our requirement is at least any one of them is non-zero. Here we have four scalars. At least any one of the scalar is non-zero, then we say that it is linearly dependent. Now, next problem. Here I am picking linearly independent case. Third problem, homework. Here I am showing second problem. Okay. So that the vectors are linearly independent. Answer. Similar procedure. Let C1 x1 plus C2 x2 plus C3 x3 equal to 0. 0 means 0 vector. 0 vector in this space is three tuples. C1, x1 value is 1, 0, 0. C2, 0, 1, 0. C3, 0, 0, 1 equal to 3 tuples of 0. Now, send the scalar inside of the vector. It becomes like this. Now, adding the vectors, because all are 3 tuples as per tuple addition, this value becomes like this, component-wise addition. 3 tuples are equal if and only if their corresponding components are equal. Now you observe that every scalar should be 0. C1 0, C2 0, C3 0. Therefore, our given set of vectors x1, x2, x3 are linearly independent. That's all. Okay. Third problem, your homework problem. Next topic, basis and dimension. Basis means a set of vectors. You collect the set of vectors. Yes, usually take some vectors in a set S. This set S is said to be a basis if the vectors in S are linearly independent. Just previous procedure. Then V is a linear combination of elements of S. By taking any vector in V, it can be written as a linear combination of S. First procedure, write down the given vector as a linear combination of vector. If by taking any arbitrary vector from V, it is written as a linear combination of the elements of S. Then we say that it is a basis. If S has finite number of this basis set has finite number of vectors, then it is called finite dimensional. So if S has infinite number of vectors, then the dimension is said to be infinite dimension of the vector space. Here we have a problems. So I am taking first problem. Here I provide the 4 problems. So here I am taking first problem. I will do 2 problems, remaining 2 as your homework. Okay. If you have any doubt, contact me. Already we proved this as a linearly dependent. Just now 2 parts to show that our intention is to show that 1 0 0 take in set S 0 1 0. These 3 vectors taken one set is a basis. It is sufficient to show that first condition linearly independent. S is linearly independent. S means these vectors, 3 vectors, already proved in the previous problem. Just now I proved x1, x2, x3 vectors above problem. So one more time, I am not interested to prove one more time. Just you copy the above answer. S is a linear combination of V is a linear combination of V is a not V is a linear combination of S, vectors of S. If you have any strictly, you write down vectors of S. That's all. So first proof for first one. S is linearly independent. As routine procedure. One more time, anyhow, I am proving. Let C1 x1, C2 x2 plus C3 x3 equal to 0. C1, x1 value is 1 0 0. C2, x2 value is 0 1 0 plus C3, x3 value is 0 0 1 equal to 0 0 0, because 0 vector in 3-dimensional space is 3 tuple. Adding this, entering the scalar inside the vector, these vectors converted like this. Now by vector addition, the left hand side value becomes like this. As per order pairs, order triples are equal if and only if corresponding components are equal. Now all 3 scalars are 0. Therefore, S is linearly independent. First part over. Part 2. Show that V is a linear combination of vectors of S. That is, usually it is written as this symbol. That is to show that linear span of linear combination, also known as linear span of S. As your wish, you can write down in word form or likewise to show that V equal to L of S. Now take a vector. Let you take arbitrary vector A, B, C in vector space V. To show that V is a linear combination of the vectors, let A, B, C equal to alpha into first vector plus beta into second vector plus gamma into third vector. That implies A, B, C equal to alpha, beta, gamma. A, B, C. Adding these three vectors, we get like this. Now, alpha value in terms of A. Alpha equal to A, beta equal to B, gamma equal to C. Substituting these values in equation 1, substituting these values in equation 1, then we get A, B, C equal to A times of 1, 0, 0 plus B times of 0, 1, 0 plus C times of 0, 0, 1. Now adding left right hand side, we get the LHS. So taking any vector A, B, C in vector space V, it is written in the form first component into first vector x1 plus second component, third component to third vector. So it is a linear span. So hence the given set is a vector space. It means a basis of the vector space. Now, second problem. Second, here you write down, therefore S is a basis. Dimension is 3. Dimension is 3 because in S we have 3 vectors. So first problem over. Now I am going to prove second problem. Okay. Remaining to do yourself as a homework. So here we have 3 vectors. Let, as is your same procedure, set S equal to, you take given vectors in a set. If already they mention in the set, no problem. You take whatever they given as a set. If they are not given in the set form, you take in a set. Give the name of the set as S. To show that S is a basis. S is a basis. It is sufficient to show that sufficient to show that first condition, S is linearly independent. Second condition, vector space spanned by, linear combination of vectors of S. First condition, S is linearly independent. So start as usual routine procedure. C1 times of x1, C2 times of x2 plus C3 times of x3 equal to 0. C1, first vector name as x1. For understanding purpose, I give the name. By the practice, no need to give the name. This vector nothing but 1, 1, 2. C2 times of second vector. What is the value of second vector? You observe that 1, 2, 5. 1, 2, 5. Third vector. Third vector value is 5, 3, 4. 5, 3, 4 equal to 0 vector. So by the practice, you reduce the steps. One more thing, based on the marks also, you can reduce the steps. But here I am providing all the steps. C1 plus C2 plus 5C3, first component. Second component, C1 plus 2C2 plus 3C3. Third component, 2C1 plus 5C2 plus 4C3. 0, 0, 0. Equating the corresponding coefficient. Find First component 0. Second component 0. Third component 4C3 equal to 0. If you have any interest, you can apply the matrix method. You can solve. Otherwise, elementary section from first two equation eliminate C1. From second and third eliminate C1. We get a C2, C3 equation. Find C2, C3. Substituting in any one of the equation, we get C1. Otherwise, you apply the matrix method. Here I am solving by using matrix method. So elementary row operations. C2 tends to, I mean, R1, R2 tends to R2 minus R1. R3 tends to R3 minus 2 R1. 1, 1, 5. First row, no change. Second row, subtracting first row from third, second row. It becomes minus 2. Now 2 times 0. 2 times means 3. 4 minus 10. 4 minus 10 means minus 6. Once again, apply row operation to this matrix. R3 tends to R3 minus 2 R1. Sorry, R2. Diagonally domination form. You convert the matrix. Here 0, here 0, 3 times minus 6. Minus 6 plus 2 times of minus 6 minus 2 times of R2. R2 row value is 2 minus 2. Minus 2 minus 2 plus 4 plus 4 minus 2 plus minus 2. So overall this value is minus 2. Now clearly it is a Ecclong form. Now once again it is converted into matrix form. Becomes it is a upper triangular matrix. Therefore the system is written in the form. First equation becomes, if you have any confusion, write down 0, 1, minus 2, 0, 0, minus 2, into C1, C2, C3, 0, 0, 0. Actually, here this system of equations written in the matrix form. It becomes 1, 1, 5, 1, 2, 3, 2, 5, 4 into C1, C2, C3. These values are 0, 0, 0. Okay. Later I solve this. Now once again converted into equation form. C1, C2, 5, C3 equal to 0. First equation. Second equation C2 minus 3C3 equal to 0. Third equation minus C2, C3 equal to 0. From the third equation, we get C3 equal to 0. Substituting this value in this equation, we get C2 equal to 0. Substituting these two values in the first equation, we get C1 equal to 0. Therefore, by the back substitution, by the back substitution method, C1 equal to 0, C2 equal to 0, C3 equal to 0. Therefore, the given vectors are linearly independent. Therefore, S is linearly independent. Next part, linear combination. Last part. So next to show that, next show that next show that any vector is a linear combination of elements of S. V equal to L of S. Take arbitrary vector as usual procedure. Let A, B, C in B. Because it is a three-dimensional vector space. All vectors are three. And let A, B, C equal to alpha times of first vector plus beta times of second vector plus gamma times of third vector. It is alpha, not alpha 1. Okay, anyhow, this is alpha, not alpha 1. Substituting x1, x2, x3 values and solving A, B, C. Alpha into first vector is 1, 1, 5. Is it okay? 1, 1, 5. First vector. First 1, 1, 2. 1, 1, 2. Beta. Second vector 1, 2, 5. 1, 2, 5. Third vector gamma 5, 3, 4. 5, 3, 4. 5, 3, 4. Now find alpha, beta, gamma in terms of ABC. Okay, you understand? Alpha, beta, gamma, we want to find in terms of ABC. Same procedure, linear combination. Finally, equate the equations. I am writing here directly 5 gamma, first component, second component 2 beta plus 3 gamma, third component 2 alpha plus 5 beta plus 4 gamma. Now equate the corresponding vectors. Alpha plus beta plus 5 gamma equal to A. Alpha plus 2 beta plus 3 gamma equal to B. 2 alpha plus 5 beta plus 4 gamma equal to C. Now solving these equations, A, B, C are constant. If you have any confusion, write down in matrix form. 1, 1, 5, 1, 2, 3, 2, 5, 4, alpha, beta, gamma. Here we take augmented matrix. So augmented matrix of this equation is 1, 1, 5A, 1, 2, 3B, 2, 5, 4 gamma. Apply the row operations to the above equation. R2 tends to R2 minus R1, R3 tends to R3 minus 2R1. The resultant matrix becomes 1, 1, 5A. This is 0, 1. This is minus 2. This is B minus A. Now, third row becomes 0, 3, 4 minus 10. 4 minus 10 means minus 6. Gamma, I mean, it is C, not gamma. C minus 2A. It is not in echelon form. So, because here diagonal, second diagonal element 1, below 1 is 3 is there. Further, one more time, we apply the row echelon form to the third row using second row. Okay. Okay, 1 minute. Here signal problem. Okay, that implies apply the row operation. So R3 tends to R3 tends to R3 minus 3R2. 115 A 01 minus 2 B minus A. Here 0 0 minus 6 plus 6 0. This becomes C minus 2A minus 3B plus 3A. Clearly it is in row echelon form. Simplify this expression. 115 A 01 minus 2. I think somewhere I made a mistake. Anyhow, same procedure here, important to the procedure only. C 2A, here some C minus 2A, here B, not 3. This is minus 3B. So, C minus 3B plus A. Now once again convert the system into alpha, alpha, beta, gamma. Matrix into equations. So first equation, alpha beta plus 5 gamma equal to A. Beta minus 2 gamma equal to B minus A. Last one, 0 into gamma equal to C minus 3B plus A. So I think somewhere I made a mistake. This is examine or show that. Show that means my answer is wrong. Examine means examine. So examine means may or may not. So here linear combination failures. Examine. Examine means verify. Verify means may be true or false. Okay. Here S is linearly independent verification. Then next verify, not show that. Examine means verify. Here also the starting point. Here to show that, not show that, to show that. Verify. It is sufficient to verify. That's all. Examine. So second problem is not linearly. It is linearly independent, but not a linear span. So gamma, take any gamma. So from this, gamma is not evaluated. Therefore, from these two, from these two, how to find eliminating this equation useless, because 0 into gamma equal to this one, useless. From these two, solving these two, we get, subtracting second equation from first equation, subtracting, it becomes alpha. Beta get cancelled. 5 gamma plus 2 gamma becomes 7 gamma. So 7 gamma equal to, subtracting means minus a plus a, here plus a, this becomes plus a, mean 2a minus b. What about gamma value? What about alpha value? If you take any gamma value, we get alpha value. Let gamma equal to 1. Then alpha equal to 2a minus b plus 7. Now substitute alpha gamma in the second equation, anyone. Gamma equal to 1. Substituting gamma equal to 1 in the second equation. This value in this equation we can easily get beta. And beta equal to b minus a plus 2 gamma. 2 gamma value is 1. B minus a plus 2. Therefore, every vector A, B, C is a linear combination of alpha times alpha value is this one. Verify whether it is right or wrong. Alpha times means 2a minus b plus 7 into first vector 1, 1, 2 plus beta means b minus a plus 2 into second vector second vector 1, 2, 5, 5, 3, 4, 1, 2, 5, 125, 534, 125, 534, 125, 125. Third vector 1 into 5, 3, 4. Now observe that first component. First component is this value, here this into this, 2a verification. 2a minus b plus 7 first component, here b minus a plus 2, here first component 5. Finding this value. B minus b, okay. Here minus a plus a plus a. Here some sign only variation. I get some variation of the sign. Here gamma, 5 gamma. So 7 gamma, 5 gamma, subtracting these two plus 7 gamma. 7 gamma move to right left hand side, it becomes minus 7. Now here minus, not plus, minus 7. Now here minus 7. Minus 7. Now okay. Here minus 7. Minus 7. These two are cancelled. A minus 2a plus a. Second component also you observe that. Therefore, the given set given set is a S is a basis. Second problem also success. So remaining two problems, try to yourself. Okay. Remaining concepts I will cover in the next video lecture. Here I am going to stop.